Schrödinger's cat is a famous thought experiment in the field of quantum mechanics, proposed by Austrian physicist Erwin Schrödinger in 1935 to highlight the peculiar nature of quantum superposition and its implications for macroscopic objects. The scenario Schrödinger described involves a sealed box containing a live cat, a radioactive atom, a Geiger counter, a vial of poison gas, and a hammer. The experiment is set up in such a way that the release of poison gas and the consequent death of the cat are determined by the decay of a radioactive atom. If the Geiger counter detects radiation, meaning the atom has decayed, it triggers the release of poison gas, killing the cat. If no radiation is detected, the cat remains alive. Here's the crux of the thought experiment. According to the principles of quantum mechanics, until the box is opened and the cat is observed, the cat exists in a superposition of being both alive and dead simultaneously. In other words, the cat's state is not determined until it is observed, and until that moment, it's in a superposition of states. This paradox illustrates the strange and counterintuitive nature of quantum mechanics, where particles can exist in multiple states at once, and their state only becomes fixed when observed. Schrödinger proposed this scenario to critique the interpretation of quantum mechanics, highlighting the seeming absurdity of a macroscopic object, like a cat, existing in such a superposition. It's important to note that Schrödinger's cat is a theoretical construct and not an actual experiment that could be conducted on a living creature. It serves as a thought experiment to provoke discussion and understanding of the principles of quantum mechanics and the challenges it poses to our classical intuition about the behavior of particles and objects at the quantum level. Certainly, I can provide a more detailed explanation of Schrödinger's cat experiment and its implications in quantum mechanics. In quantum mechanics, particles and systems are described by wave functions, which represent a range of possible states. These wave functions can exist in superposition, meaning a particle can be in multiple states simultaneously. It's only when we make an observation or measurement that the wave function collapses to a single state. In the case of Schrödinger's cat, the key elements are the radioactive atom. This atom has a certain probability of decaying over a given period. The decay is a quantum event, and the exact moment it will decay is uncertain. The Geiger counter. It's designed to detect the decay of the radioactive atom. If it detects radiation, the atom has decayed. It triggers the next step. The vial of poison gas and the hammer. If the Geiger counter detects radiation, it causes the hammer to break the vial of poison gas, leading to the cat's death. Now, here's the crux of the thought experiment. Before you open the box and make an observation, according to quantum mechanics, the cat's state is described by a superposition. It is simultaneously both alive and dead, as the atom is in a superposition of decayed and undecayed states. Only when you open the box and observe the cat does the cat's wave function collapse to a definite state, either alive or dead. At this point, the act of observation determines the cat's fate. This experiment was designed to emphasize the peculiar nature of quantum superposition when applied to macroscopic objects, such as a cat. In reality, we don't observe cats in superpositions of life and death because the macroscopic world behaves classically. The thought experiment was meant to highlight the challenges and interpretations in quantum mechanics, including the Copenhagen interpretation, which suggests that the act of observation is what forces a quantum system to assume a definite state. In summary, Schrödinger's cat serves as a powerful illustration of the philosophical and interpretational issues in quantum mechanics, showing that the classical world of everyday experience and the quantum world of subatomic particles can be quite at odds in their behavior and understanding.